I'm responsible for rail. So we work on rail opportunities around the world, and now railways are very interested in 4G and 5G technology, and so we have engagements. We didn't sell anything yet, but soon. Indian Railways is very interested in working at LTE. You think about Indian Railways, quite a primitive operation. It's not quite so. They could be one of the most advanced railway communication companies in the world soon. Swiss, SBB, Deutsche Bahn, SNCF, they all have 5G trials running or being planned. And now from Canada, we also have 4G from Canadian National Railways. CN has also issued an RFP. So the industry is really moving very rapidly into the interest of 4G and 5G. So I'm going to talk a little bit about Ericsson, because not all of you are familiar with Ericsson. Why cellular is important. We'll talk about 5G telemetry for rail, and I'll explain the difference between 5G and 4G. There's a lot of misunderstanding about 4G and 5G, and a summary, I guess, and you can ask questions. And if you raise your hand, if you don't understand anything, don't be shy. You can stop me at any time. It's like an informal discussion about rail and telecommunications for rail. So a little bit about Ericsson. So we have different business areas, networks. I work for networks, so my goal is to sell the radio interconnect along the rail track in the long term for the railways, or the mobile network operators, that they should provide the coverage along the rail track. Digital services, this is our core, where we have all the communications infrastructure for setting up calls and billing and things like that. Managed services, we manage networks on behalf of our customers. And we have technologies and new business. This is where IoT fits in. So Internet of Things, this is the segment that you're in, where you have small devices that are connected. So we manage, we don't make any end devices, but we have a system which manages end devices like these little things connected to the rail. We work in 180 plus countries, 210 billion SEK in sales, 94,499 employees, I guess of that date of this slide was made, and 45,000 patents. So we have a pretty big operation here in Netherlands, in Riehen, not far from here. Our presence in North America, South America, and Europe and Latin America, we have about the largest presence, I guess. In China, we're also active, very active in India, in Australia, and small presence also in Africa as well. So we're going to jump now to what the railways need. We'll take ProRail, the Netherlands railway infrastructure operator. What do they need? Level crossing protection, number one. Wayside telemetry, and I focused on this, and I didn't put this here because I'm here at Strukton, because you made wayside telemetry, but that's one of the key use cases we see. Monitoring onboard services and CCTV. Right now, if you take a train, NS train, okay, there might be cameras on board, but they're not sending anything in real time. So if you report an event, a security event, there's smoke on the train, nobody in any central control area can see in real time what's going on. In 2013, they had a Christmas bomber in Berlin, for example, and he killed 12 people in the Christmas market in Berlin, and he couldn't find him for 5 days. Why? Because he got on a train, and he kept on going on trains for 5 days, and when he got off the train in Italy, suddenly he came on the CCTV cameras and was arrested. So if you want a hideout, the best hideout is the train. So that has to stop, and the way it can stop is to have infrastructure that can deliver images on board the train in real time to a central control center. Train telemetry, so trains now modern trains have millions of sensors on board, the door motor, the air conditioning, the level of the fuel, all this can be sent in real time to an operations center. Passenger information systems, traffic management, I put here in push-to-talk group communications. So this is for the driver to use and for the security employees and the conductor to use to talk to each other or to the control center. Or so this is a product, I put it in purple, which we are developing as well. And train control, which is a very important application. The trains today, if you take a train that's going anywhere above 180 kilometers per hour, the driver can't see the signals anymore. He's not able to see if it's red or green. What? I missed it. I was looking the other way. I missed it. He needs in front of him all the information that he needs in order to control the train, where the red lights are ahead and the green lights. And there has to be more automation in terms of preventing him from going too fast and around a curve. So train control is a fundamental part of how NS and ProRail run the trains, especially when they're going on high speed, like a Thales train. Thales train has to go with train control. Okay, so when we deliver these applications, what are the network requirements, the underlying network to deliver all those things that I talked about earlier? What do I need it to do? What are the characteristics? First of all, availability and reliability. Because if this network stops, if your smartphone stops suddenly because of a problem with Vodafone, suddenly in the core, okay, you're annoyed. You go on with your life until your smartphone comes back into service. But the train stops. It'll stop between stations. It won't be able to run. That's really annoying. So we need 5 nines availability. The communication infrastructure can have no single point of failure. And the coverage. So if I take Vodafone again, Vodafone Ziggo, it may not cover bridges across the Rhine very well because how many customers are living on the bridge on the Rhine? So the coverage might be spotty. But the train going across that bridge needs to have fantastic coverage. So the coverage has to be more than what Vodafone Ziggo can offer. Generally, they have to supplement it in these areas where it might be bridges, it might be tunnels, it might be cuttings. In fact, I took the train from Schiphol to Breda, and every time we went into a tunnel, no coverage. So we can see that, I forget who I was, KPN. I was on KPN's network. They don't have coverage in the tunnel. So certainly you need to supplement that. One of the other characteristics is low latency. So if I have things like a level crossing protection, train control, or monitoring, sometimes I need to react really fast. If that alarm goes off, I need to react and put the red light on within a millisecond. So the reaction, the fast reaction, that's low latency. I need that in a communication network. I also need the capacity. Capacity, and one of the big capacity challenges is that video I was talking about. So that video needs a lot of bandwidth going uplink. Typically, mobile communication networks, they're more suited for downlinks. They give you the YouTube so you can run YouTube and you're happy watching your YouTube. But you're not sending uplink that much YouTube stuff. So there are more downlink. Railways, the ratio between uplink and downlink is 17:1. So they need more, 17 times the uplink capacity as for downlink. So that's a big challenge for configuring the communication networks that will meet what the railways need. What's the advantage of using LTE in terms of railway? So today, the current status, if I take ProRail, I take NS, they use something called GSMR. GSMR is a 2G technology, second generation. It was invented in 1996. So, and it started to become widespread in about 2000, 2001. So we're talking about 20 to 25-year-old technology. That's running the trains today. And it's used for operational voice and for this ETCS train control. That's all it can do. It's like a GSM phone. So you have a GSM phone, you find it on the street, you won't even bother to pick it up because all it can do is voice and SMS. I mean, it's useless, it's not even worth 15 euro. But that's what the trains are running on. They use voice, and instead of SMS, it's the train control signals. They're missing all the applications that come in a phone. So you wouldn't go around in your pocket with a GSM phone because you need, and your life surrounds the applications. What we introduce to the railway when we go to 4G and 5G is all these applications that you have in your phone, but they don't have in the train. So things like what they have today, ETCS Level 2, platform monitor, the video, operational voice, CCTV, passenger information systems, train telemetry. All these applications can't run on GSM-R because GSM-R is a very narrow capacity. It's a very narrow pipe. They need to establish parallel networks. So sometimes they will establish parallel Wi-Fi networks in order to supplement the connectivity. Is it okay? Can you hear? Okay. So that's the advantage. So cellular, when I talk about cellular, this is going basically why cellular versus Wi-Fi? Why cellular and not LoRa? Why cellular and not Sigfox? These LoRa, Sigfox, Wi-Fi, they're all unlicensed types of communication. They don't have the same capacity and coverage that 4G and 5G have. They don't have the same ecosystem. So I don't have a phone that does LoRa. There's no such thing as a phone that does LoRa. So I can't do voice over LoRa, for example. So with 4G and 5G, I can run all the applications with a standard handset. It doesn't have the low latency we talked about earlier and the reliability. It doesn't have the flexible deployment, the core. It's very fixed. It doesn't have the security that 4G and 5G have. And it doesn't have the mobility. So if I'm of a train, it's running LoRa, it's only in that area. So if I run, for example, the train runs into Belgium and it runs on Infrabel infrastructure and MBS infrastructure, completely different. But when all the railways go to 4G and 5G, wherever the railway runs, it'll have the common infrastructure. So those are the big advantages. Where does Ericsson sit with this? So we have a large radio portfolio where we make the low band radios. That means bands of 800, 900 megahertz, mid band 1900, 2100. We have what's called massive MIMO. Massive MIMO is multiple input, multiple outputs. And these are antennas which are able to send parallel streams of information. So with parallel streams, my capacity increases tremendously. Fixed wireless. And now we see 5G, for example, being deployed in the United States. They're one of the first countries to deploy 5G on a massive scale. But they're doing it in very high frequencies, 27 gigahertz. 27 gigahertz. This is for fixed wireless. That means they can reach any home. They put a tower in a neighborhood with 5G, 27 gigahertz, that can see from the tower, top of the tower, see the top of every home. Then you don't need fiber to the home, and you don't need a cable anymore. It can reach everything without digging up the road with capacities just like fiber. So that fixed wireless at 27 gigahertz, it'll take the cable companies and the fixed wireless companies out of business. They don't really, you don't need them. They become relics. Indoor dot radio. So we have a radio solution that looks like a smoke detector, and it's like a base station for giving 4G and 5G coverage in any room. And we have an application that you can locate anybody in the room. Within 4 or 5 meters, we can add location as well. Transport, that's connecting the different parts of the network together. IoT RAN, so this is a type of configuration of the radio access network where we can deploy these devices, thousands of them, hundreds of thousands of them in a network, and be able to manage them and provide prioritization for the important ones and provide the capacity so they can all communicate seamlessly. NR is the 5G RAN. So NR stands for new radio. This is the new type of radio that's coming out that I mentioned, running in 27 gigahertz directly to the home. And using that MIMO technique where we can have massive amounts of information sent. On the core, we have mission critical push to talk. I'm not going to go too much in detail about our portfolio. The next standard for railways to use, ProRail, NS, when they go to the next generation, beyond GSMR, based on 4G or 5G, it's called FRMCS, Future Railway Mobile Communication System. Right now, they're working through all the standardization bodies, getting the right spectrum for it. It takes many years of discussions at the EU level and at the DITT level, which is the standardization body for Europe. They expect to have standardization ready in 2021, and then the railways will be able to deploy equipment in 2023. That's when this FRMCS. Now, Ericsson, it's not a player in the current GSMR that I talked about. And it's an advantage and a disadvantage. The disadvantages, we don't have any railway references. You can ask Ericsson, where are your railways around the world that you've connected to? I don't have any. But my competitors have GSMR, but they're interested in getting GSMR to work as long as possible. So I don't have that disadvantage. I'm not interested in getting GSMR to work as long as possible. I want to kill GSMR as soon as possible. So that's basically my advantage. And I think the railways understand that. We have a big portfolio of mission-critical networks. So we talk about railway, what I need to give to ProRail, what I need to give to NS. We said that earlier, if the network stops, the railway stops. So we consider it mission critical. We have mission critical networks, and one of the biggest ones is FirstNet in the United States. After 9/11, the towers collapsed. They discovered that their communication networks were completely overloaded and congested in a real emergency. So the United States government allocated a big budget for modernizing it and making it an LTE-based network, and they call it FirstNet. It's serving the police, fire, and ambulances from coast to coast in the United States. It's run by AT&T, which is one of our major customers. So 60% of AT&T's FirstNet network is run on Ericsson equipment. And we also have Verizon, which is competing with that, with a competing solution coming out very soon. So we have a lot of mission-critical networks. Home Office in the UK. We have Swisscom Broadcast in Switzerland, and we have in Australia. So a lot of mission-critical networks which have that 5 nines availability requirements. 5 nines means 99.99% availability. So a few years ago, when I started this about 4 years ago, I said, I need to be able to demonstrate this because people won't believe that LTE is better than GSMR until I show them. Well, now we were able to convince Deutsche Bahn to set up a German railway, to set up a 30-kilometer test track between Ingolstadt and Nuremberg in Bavaria. And on that track, we have LTE radio. We have trains going 200 kilometers an hour. We also have a highway next door. So it's called the A9 corridor, where the A9 highway runs. So we'll also be able to work with BMW to test cars working along that, to communicate with telemetry and infotainment and all sorts of IoT applications for automobiles. And using the same infrastructure, we have test trains running up and down, testing different applications as it goes between the things. And we have something called network slicing. So network slicing, I take a network, which could be Deutsche Bahn's network, or it could be Swisscom's network, it could be Vodafone's network. And I slice it. That means I take it and I isolate parts of the network and resources for specific applications. So if I have something like IoT, or the network that sends the information from these track temperature monitors, I can isolate it and I say, okay, I need a specific uplink capability. Let's say it could be 500 kilobits per second. And I want it reserved. So make sure that that particular track sensor always gets that 500 kilobits per second when it's needed. So that's called network slicing. If I have that guaranteed end-to-end isolation and guarantee of the throughput for that particular device, then that's network slicing. So we're able to slice a network so that many different users can be guaranteed what they need. So when the train comes into the station, it's guaranteed the access that it needs. And when the train's not in the station, then the passengers are able to use whatever the train is not using. So it's a situation where we're also able to do dynamically. So here we test different types of applications. We have something called machine type MTC, which is machine type communication. That's these sensors here. We also have mobile broadband. That's people watching YouTube. And there we have called passenger entertainment, where they're being fed an entertainment stream from the, I think if you go on Virgin trains, for example, you get that stream. You can watch movies from the Wi-Fi of the train while you're riding the train. So we have those three different streams. And here, I was on board here. Here we have the testers on board the train as it's going, speeding along the track at 200 kilometers per hour. And here I have three devices. This is an IoT device, like a sensor. And this is two devices that are, one for passenger entertainment and one for watching YouTube. We also have a lab in Aachen, not far from here. In Aachen, Germany, we have a lab set up at Ericsson in order to test devices end to end. So we can test applications. I have a radio down here, Ericsson radio, and I have a device here that can simulate the way that the radio waves work if the train is running up and down the track at 360 kilometers per hour. And this is on board the train, what simulated a router, and then I have simulators, and I can generate traffic, and I can analyze the traffic, and I can determine exactly the performance of the data that's running under any condition. So I can test any type of application and test it at any type of railway condition, no matter how fast the train could be running along the track. So when I tested it together with the Bombardier and Ansaldo a few years ago. We got to very low latencies, 6.6 milliseconds, which is quite low. If I'm talking about GSMR, for example, it's about 100 and 150 millisecond latency. But here, I even overloaded the network. So the packet loss for what I call Wi-Fi, which was LTE, passenger entertainment over Wi-Fi, it was at 30%, 30.7%, 20, very high packet loss. The railway, this network is completely overloaded. Yet, nevertheless, I have the low latency for the train control, because the train control is the most important. I give it prioritization. So I'm demonstrating here that even under the worst conditions, the train control, which is the most important element and makes the train run, it always gets priority and it gets the best service. We also have something called Industry 4.0 at Ericsson, and this is our connect solution for factories. So factories today, a lot of them are using Wi-Fi. So factories they have cables running, like you have cables here, running between the different machines. So if I have an auto assembly plant for electric vehicles, I might have cables running all the robots, but then I decide I need to move. I'm changing it to a different model. I need to rewire the whole factory to a new configuration. But if you run it at 5G, then they're all wireless devices. I just push basically the robot to its new location. I don't need to wire it because it's connected to 5G. So the whole all these modern factories, instead of rewiring them with cables and fiber, you connect them with 5G, and then it's much more efficient. It has interference protection, low latency, prioritization for the important robots over the non-important robots. So the future are going to 5G, and we have many different references. And if I think about in the railway, a railway freight yard, for example, it's like a factory. So it has many different sensors in a small location. It might be 1 or 2 kilometers. And I can use the same analogy to introduce into a freight yard Industry 4.0, the same kind of applications that I do in the factory. So industries, they go from 4G to 5G. So in 4G, I have enough capacity to run massive IoT, a lot of these end devices, or broadband IoT, which are video cameras. But then when I want prioritization, I need the criticality, I need the low latency, then I need to go to 5G. Only 5G provides that criticality to do collision avoidance, automated operation, or collaborative robotics. That means the robots communicate with each other at high speed. So that's how we move from 4G, what the requirements between 4G and 5G. If I take, for example, I mentioned before cables, inflexible production, and Wi-Fi has performance restrictions, whereas with 4G and 5G, I overcome that. And if I take that box over there, which is typically connected into a switch room, this dual device used for a track circuit, if I converted that into a wireless 5G, so I can put into the switch room on the ceiling a 5G radio, and then have wireless sensors like that, and then I don't have all the cabling that you have here. You don't need all that cabling. The cabling needs special certifications. You avoid that. So it's one aspect that can be simplified by introducing 5G. Questions? Yeah, so POS, I thought POS was, so POS is the Structon system, which has sensors, wired sensors in the switch room, which monitor the turnout machines. So the switch motor, we don't have a turnout machine, but if you have, for the tracks, for the train to go from this track to this track, there's usually another track that joins them, and there's a motor that moves that little track, and it's called a switch motor. So POS is a Structon product that monitors the performance of that little motor. So if the motor starts to get ill, not feeling well, you know in advance that it's starting to not feel well, and you can send a maintenance technician to replace the motor. Whereas today, without POS, you need every week to send somebody to the track, test it out, because if that little motor fails, the whole track is gone. The trains can't run on that track. It's really important. So POS saves the railway a big headache in making sure that the railway works well. But the POS is wired in the switch room, and it's a huge jumble of wires going around. Every time you put a new wire into that room, it affects life-saving relays. All the relays that protect the rail network could be affected, so it has special certification in order to put every sensor in there. Now, if you work with wireless sensors, you don't have any threat or risk of short-circuiting another circuit, so wireless sensors need much less certification in the switch room. So it's an idea that possibly can improve POS and make it more efficient in deployments in the future. I think I'm going to skip this. We also have things like augmented reality. So 5G sends images very low latency to the very quickly to a goggle. So if you have a headset with an image, you can do hands-on maintenance. So if I need to maintain something and I want the instructions, I don't need to have the paper in front of me with one hand and have the screwdriver running with another hand. I can have the image on the goggles. When I'm looking at that, they'll have the whole instruction manual projected, or the instructions I need to do on the screen in my helmet, and then I have both hands available to operate whatever I need to do on the track. So it's a lot more efficient to use augmented reality for field maintenance activities, but every time I turn my head, it should have a different image or different information projected on the helmet, and that's low latency. So it has to know I'm looking at that particular piece of device, what instructions, only when I'm looking at that piece of device. You need low latency to have that kind of very fast reaction time. So we have, in that arena, we have many different partners in that IoT that make end devices or the parts that go inside that device. So those might have a Sierra Wireless modem in there, and Sierra Wireless is one of the partners here. I talked about 4G and 5G. So we talked about throughput and things like that, but there is more to 5G than just the throughput. One is network slicing that I indicated earlier. So 5G allows me to slice the network. That's something 4G really doesn't have very convenient. It's possible, but in a fixed way, not in a flexible way that 5G. The network architecture is much different. I can distribute the parts of the network all over Netherlands. I don't have to have the core in one place, so I have to have low latency, some parts that need fast reaction. I can put parts of the network in Breda and parts of it in Amsterdam. It can be distributed. The quality of service, in 4G, it's much more fixed. It's fixed on bearers. These are like pipes that I assign each type of service to a pipe. Whereas with 5G, I can make granularity that every device has its own unique flow. If I take policy, for example, also, the policy framework is unified with all the access technologies in 5G. That means I can set up a 4G access, a 5G access, a Wi-Fi access, a satellite access, running on the same 5G core with a unified policy for all those accesses. Only 5G can give you that kind of capability. So in terms of the railways want the flexibility to go between 4G, 5G, Wi-Fi, satellite, and 5G core gives them that capability. They want to do network slicing. Network slicing also gives them the capability of getting from Vodafone Ziggo a network slice when they want to use that video I was talking about. So the network slicing, only 5G can provide. So that those combination of the quality of service, the different types of access, the network slicing, those three key reasons determines that railways will all use 5G core. That's basically what they're going to be using. So the 5G core, I'm not going to go into details here. This is what it looks like. Yeah, questions? Yeah.
I can imagine 5G is better, of course.
Yeah.
But you are talking about trials with 4G
Yeah.
in Germany.
Yeah.
So it is also possible to manage trains with 4G, isn't it, in a safety way?
So let's go back to the trial in Germany, which you mentioned, okay? So the trial in Germany, that long stretch of 30 kilometers of highway, that works in the 700 band, okay? It's working in 700 megahertz, and I have towers perhaps 5-6 kilometers apart, okay? Right now in 5G, I have very few radios or infrastructures or devices available that work in such a low band. Now, the next phase is to go to the freight yard in Nuremberg, which is only 1 or 2 kilometers long, and there I can put 3.5 gigahertz, a higher band, with 5G, which is available off the shelf today, and do use cases like the video, IoT, in the freight yard with a distance of the tower to the train of only 1.5 kilometers. So that's the difference why 4G today versus 5G today. In the future, I can run 5G also in 700, but it may take a few years before that ecosystem is available. Does that answer your question?
Yeah, part of it. So when I asked the question, in a way, is it possible to start tomorrow with 4G?
Absolutely. Okay. Now, let me just take about ProRail right now, okay? ProRail is going to use FRMCS, right? Now, right now they're running this GSMR, 4 megahertz wide band between 921 to 925 megahertz. What they want is to operate a little band right next to it, but the little band is only 1.4 megahertz wide. That low, under 5 megahertz wide, you can only work with LTE. So even ProRail, when they introduce their network in 2023, the access for that 900 band is going to be LTE, for sure, okay? Now, I'm encouraging them to consider also 1900, which is another band available to them, which can run 5G. So it's up to ProRail to decide, will we go to David's recommendation of 5G or 1900, or will we go to the LTE adjacent to my GSMR? That's a big debate right now in the railway industry. They could get both. It all depends what they decide. So it's 4G and 5G access, depending on what they need. Now, a 5G core that I was talking about can run a 4G access and a 5G access, LTE and 5G. There's no limitation. Okay, so I mentioned earlier when they go to that LTE, it's only 1.4 megahertz wide. That means at the cell edge, perhaps they can only run 100 kilobits per second, which is quite low. It's enough maybe for that ETCS to run and a little bit of voice, not much. But if they go to 1900 with a 5G, I can give them 3 megabits per second at the cell edge. So it's a difference in performance. I can provide them more that MIMO, which is, I can't do that much in LTE. With 5G, I can provide parallel streams of information from the antenna to the train. So 5G has greater throughput. I talked about network slicing. So with LTE, I can't do network slicing from one device. I can assign a network slice to each device individually. But one device, if it's running YouTube, voice, IoT, different applications, I can't assign a different network slice from one handset towards the different network slices. In 5G, I can do it. So in the locomotive, I might have one radio connected to the antenna on the roof of the train, one radio. So I need, on board the train, I might have different systems. The ETCS, the train control, the video, the push-to-talk voice, IoT telemetry, all sorts of devices on the train that each need a network slice. Running one little radio that's connected to the rooftop. Only a 5G access can I provide that kind of capability. Is that explain the difference between 4G and 5G? Okay, I'm not going to go through this. This is a little bit too detailed. I'll share the slides with you later on, and you can learn a little bit of the 5G core architecture. A little bit too technical, I think. Just about 5G today, they talk a lot about 5G today. Perhaps Vodafone Ziggo and Netherlands operators are starting to deploy 5G. They do it within an LTE core, which we upgrade to call the 5G EPC, and it's called non-standalone. That means every tower needs a little bit of an LTE to help it. The control signals are sent over LTE still, and only the user traffic, the traffic itself, is sent over NR. So that's called non-standalone. But the railways will go to standalone. That means that everything runs over 5G, and it runs with a 5G core. So it's a little bit different than the way deployment of Vodafone is going, because Vodafone has a lot of infrastructure right now, EPC. So Ericsson, Nokia, Huawei, we gave them a migration plan that's easy. They can reuse their assets and introduce 5G slowly. ProRail in 2023 is going to launch a completely greenfield operation from scratch. That means they can go right to a 5G core. That's it. Any questions? Yes? The obstacles to implementing 5G. Okay. So I mentioned spectrum. Spectrum is a key obstacle. So if ProRail decides only to use the 900 band and not the 1900 band, then they can't use 5G access. They'll be limited. Unless they go to Vodafone and say, give me a network slice of 5G. So there's a lot of, in terms of what spectrum you have available, the devices also have to be made to support 5G in that band. So one of the big obstacles I see is going to be the ecosystem. Because if the railways say, let's say I want to use 1900 and I want to work in 5G, then I have to go to Samsung and all the handset vendors and say, guys, can you make a handset that supports 1900 for the railways? Can you do that? And they say, okay, how many millions of handsets do you want to order? And I say, no, I only need 100,000. 100,000. We don't change our production line unless it's 1 million orders or more. I'm not going to change my production line. So I'm trying to push the railway industry and says, guys, why don't you go to Amsterdam Metro and all the metro operators that also have challenges for their urban railways and use that 1900 band not only for the intercity rail, but for urban rail too. Why don't all the metros in Europe or all the metros in the world use that 1900 band? Then I can get close to that 1 million devices that Qualcomm is going to dictate. So the ecosystem is going to be a big challenge for the railways in the introduction of 5G. Because Vodafone and all the other mobile network operators, they all have millions of subscribers between them, so no problem. But if the railways have a unique band, they're going to have trouble convincing Qualcomm to make the chipset to support them.
Is there any difference for you for ETCS level 2 or ETCS level 3?
Excellent question. Excellent question. So what is ETCS level 2 and what is ETCS level 3? So just for example, ETCS level 2, it needs the detection of the train from this track circuit. There's a track circuit that this is testing, and that's going to a wire to a control center that's basically coordinating all the sensors it's getting in the rail system to get a one picture, and then it tells the train, okay, the track ahead of you is free, you can now go 160 kilometers per hour without problem. So it gets the detection of all the information from the track, and then it sends communication over the radio to the train on what it's a movement authority, what it's allowed to do. With ETCS level 3, all this junk, sorry for the thing, gets thrown in the wastebasket. Because why do I need a track circuit in order to detect that the train is at a particular location? Have you heard of GPS? So GPS, I can report over the radio the location of the train. So if I can report over the radio of the location of the train, why do I need this junk to report the location of the train? Isn't it a waste? All this cabling, all this junk. One little GPS receiver in the locomotive will replace all that stuff and send us to ETS level 3. Does it sound like a good solution? Raise your hands. But there is a fly in the ointment. Of course, okay. So if I'm talking about a passenger train, I know the length of the passenger train. I know it's an 8-coach train. It's completely always an 8-coach train running on this line at this time. But what if it's a freight train? How do I know the length of the freight train? I need, for this system, ETCS system to work, I need to know not only the location of the front of the train, I need to know the location of the back of the train. And that is the challenge. Because at the back of the train, it's just a wagon with no information on it at all. It's just a wagon carrying a load of lumber. That's all is on the back of the train. So how do I determine the location of the back of the train? Reliably, 5/9 availability. If you can solve that problem, you can move to ETCS level 3 and throw all this junk out. Okay, so with 5G, I can have perhaps communication between the front of the train or the back of the train. With 5G, I can have a low-power device clamped on to the last car of the train to send that GPS information reliably up, or I can have 2 devices so that I have full reliability. So with 5G, I can introduce the solutions that bring me to ETCS level 3, and all this junk gets thrown to the museum. Tunnels? Okay. So I mentioned indoor. We have indoor solutions. I can put a thing that looks like a smoke detector on the roof, and it'll locate everybody in this room to within 2 or 3 meters. I can put that same thing in the tunnels, and it'll locate the train within 2 or 3 meters. Absolutely. So that's exactly a use case that I was talking about, because they usually do track maintenance at night over 30-kilometer stretches. So the problem is that you needed line of sight. So you need to be, I can't rely on the towers that are in ProRail's infrastructure today, because they're 8 kilometers apart. But every maintenance crew has a yellow train, the maintenance train that comes with them. And they usually have line of sight to that maintenance train. Now, one of the nice things about 5G is I can make an independent 5G system to serve the maintenance crew. So I can have an LTE, a 5G system just for the maintenance crew with the core on that little yellow maintenance train with an antenna, line of sight, and then I can locate everybody there within 5 meters or 3 meters. And then if they go from their maintenance track to an active track, I can send a warning to them in real time by vibrating their bracelets or sending them, flashing their helmet or whatever to warn them of a situation. So this is a use case with 5G that we can introduce more efficient maintenance activities, safer maintenance activities for the railway.
That's the beginning. View on the Indian Railway. I have a view of Indian Railway, but you said they might be the most modern soon.
Yeah. So Indian Railways, and they're involved at all levels, even Prime Minister Modi. He says, I need the trains to run safer and more efficiently between the stations. Now, if you see any of these Hollywood movies about India, Slumdog Millionaire or Lion, all these stories about India, there's always the train is one of the main features of these movies. But it's true. The train is a main engine of the Indian economy. Now, you see all these movies and films about people riding on the roof, and they don't even close the door on commuter rails. But they decided that LTE is the most efficient way to make the trains safer, and run smoother. So they have an ambitious plan for pan-India to set up an independent LTE network for Indian Railways to use and put LTE, ETCS level 2 over LTE. So it needs a reliable communication path. LTE provides that reliable one. They went to Europe and they said, okay, what should we be doing? Advise us. And they said GSMR. But I told them a year ago, you're wasting your money to put a GSM 2G network invented in 1996 in your network in 2021. It's stupid. And they believed me. So now there's an RFP that basically for that. And hopefully it'll change the industry, because if they're successful there, Europe will look at India and say, guys, how come we can't do that? They have guys riding the roof of the train and they're more advanced than us. Not possible.
Thank you very much.
Okay.